Okay, so we continue in section 1.2. These are objectives 4 and 5. Objective 4 is rational functions. A rational function f is a ratio of two polynomial functions, p of x and q of x. So it's rational if it can be written as polynomial 1 over polynomial 2. Now, you have to be broad in your thinking about what a polynomial could be. The domain consists of all values x such that q of x, the denominator, is not equal to 0, because you're not allowed to divide by 0, and any x that makes you divide by 0 is not allowed. Now, 1 over x is a rational function. This is a very simple example. So yeah, 1 is a polynomial. It's a ratio of ax to the n's. It's 1x to the 0. The domain is of this rational parent function, also known as the reciprocal function, is everything except 0. Obviously, x is not allowed to be 0 if your function is 1 over x, because you can't have 1 over 0. Here's an example, maybe more typical, of a rational function. You know, rational kind of means fractional, right? In some sense. Rational means fractional in some sense. Here, it's a fraction of polynomials. Before we talked about rational numbers, and those were numbers that can be written as fractions of integers. But these are rational functions which can be written as fractions of polynomials. So f of x here is 2x to the fourth minus x squared plus 1 all over x squared minus 4. That's a typical looking rational function. The domain is the set of all x such that x is real and x is not equal to 2 and x is not equal to negative 2. Not really the right way to write that domain. It's poor form because it can't be the or, it needs to be the and. But this symbol here incorporates the or. Anyway, we get the idea. Its graph is shown in the figure, and as you can see, a rational function can have a pretty crazy graph. Algebraic functions. Okay, now we know what algebra is. What are algebraic functions? This is going to require some careful distinctions. A function f is called an algebraic function if it can be constructed using algebraic operations, such as addition, subtraction, multiplication, division, and taking roots, starting with polynomials. So if you take polynomials, we know what those are, and you run all those kinds of operations, then that's considered algebraic, as opposed to other functions, which we'll talk about in a moment, which are not algebraic. Any rational function is automatically an algebraic function. And here are two examples of algebraic functions. And you can see how they've taken polynomials and done different things to them. Graphs of algebraic functions, all bets are off. Okay, variety of shapes, so could be crazy. An example of an algebraic function occurs in the theory of relativity. The mass of a particle with velocity v is. So mass here is a function of velocity v. You can see that your function here has the variable v And then it's just a bunch of constants around it, really, and some different operations. M naught, or M null, is the rest mass of the particle, and C, which is 3 times 10 to the 5th, or 300,000 approximately, is the speed of light in a vacuum. And we will look at some other functions which are not algebraic in the next video. Trigonometric functions, they're not algebraic because you can't write them as starting with polynomials, a finite number of them anyway, and do regular operations to them in order to get the functions, the trigonometric functions, and other what are called transcendental functions.